We have another example on the board. I'm going to start solving this problem from finding the resistance. Please notice that this is series circuit. We have given current. So it means that this current represents the current which will go through the resistor, the current which will go through the inductor. Okay, so this is my also total current. I have true power. So I have two pieces of information at the resistor. Also, I have two pieces of information at the inductor. But I'm going to start from finding the resistance. We have formula for power which says power is equal I R square times resistance. I'm looking for resistance. Power is given, current is given, so I can find very easy resistance. Divide this formula by IR square. IR square. So I'm going to obtain resistance is equal power over IR to the second power, which is equal 85 watts divided by IR, which is 420 milliamps to the second power. Resistance is equal 481.85 ohms. Okay, so this is the value of my resistor. Next, I'm supposed to find Z total. I have resistance, I have impedance of the inductor. I can find very easy Z total, total impedance. Z total is equal resistance plus ZL, where resistance we found is equal 481.85 ohms plus ZL, which is equal 1.2 kilo ohms and angle of 90 degrees. You cannot forget about the angle 90 degrees, which is going to be always next to the value of the impedance of the inductor. So I have Z total equals 1.29 kilo ohms and angle of 68.12 degrees. Okay, this is my Z total. Next, we're supposed to find the angle which will supposed to go next to the magnitude of my total current. You're supposed to realize that anytime we talk about the current in the series circuit, so this is nothing else, just I total, this is also equal to IR, this is also equal to IL. This is equal voltage source over Z total. But someone is going to say, but we do not have voltage source yet. But don't worry about it, we're supposed to just find the angles. So as I said before, we are going to assume at this level that voltage source is going to have always angle 0 degrees. And Z total has angle 68.12 degrees. So this is equal, this magnitude, 420 milliamps and angle of negative 68.12 degrees. Keep in mind that anytime you divide complex numbers expressed in polar forms, you're supposed to subtract the angles. So 0 minus 68.12 is equal to negative 68.12 degrees. And this is my, I can say, complete value of current. Next, I'm supposed to find the voltage source. Okay, so voltage source is equal I total times Z total, where I total is equal 420 milliamps times Z total, which is equal 1.29 coulombs. I do not include the angles because I assume that this voltage is supposed to have angle 0 degrees. Okay, so we have voltage source equals 541.8 volts and angle of 0 degrees. Next, we're supposed to find the power factor. Power factor is equal cosine of the angle which I have next to Z total. So I have cosine of 68.12 degrees. So power factor is equal 0.372 lag. Why lag? Because my angle is positive and because I'm dealing with the RL circuit where the current is lagging the voltage source. Next, I'm supposed to find QL, reactive power. QL is equal IL square times ZL, where IL is equal my current 420 milliamps raised to the second power times ZL, which is equal 1.2 coulombs. This is equal 211.68 VAR. Now I can say that the problem is solved.